Hey, what's up guys? On today's video, we are going to talk about method. If you have experience with another programming language like Java, you probably very familiar with the class, which is like a class, you have a property and you have a method. But for Go, we don't actually have a class. We have something similar, but it's not called class. Because like Go programming is like a functional programming language, so we don't actually have a class. So, but we have something very similar like method. So let me just give you an example. So to method declaration, this is the example. Like we have a type of struct here. And we have a method here. Method is like a function in Go, but it's like it's the particular type of function. So on the function name, before the function name, we have something called receiver. So receiver that receives the as example here, we receive the struct type point. So it's by doing that, we pass the struct like point to the receiver. It's like we link this method or function to this struct, to this type. So this is not function anymore here. We call it a method. So in order to use this method, so we have to initial the struct, assign that to P. So after we assign we initial the value here, right? So we are able to call the method here. So we declare the method like this. So yeah, it's like on this example, this is a struct. You can be any other types. You can be a slice. Then as long as we have the we use the receiver here. This is very important. It's that we link the function. It's like in this struct, we add this property. We add this method to this type, and when we assign this initial the value here, and we're able to call that. So that's the method declaration. So let's move on for method with the pointer receiver. So that's the very common one in Go. Let me just comment that out. This is a very similar, very common in Go programming language. So this is like similar to the example we have on the first one. We have a struct type called point, and we have a method called scale by, and this is the receiver. But on this receiver, compared to the previous one it passed the value here. But on here, this is past the a pointer. Pointer on here, it basically we don't pass the value of the pointer. But when we initial the value here, we don't pass here the value here. So instead, we passing a pointer. It's like a memory address. So we pass in the memory address. So instead of copy this value, so this value could be like a lot. It could be like 10 or thousands values here. So if we don't do with the pointer, it's gonna be like a low performance. And the reason why we're doing that with the pointer is that we can only copy the address, memory address in there. So we can modify that. We can modify this value. So by doing that, so we call the method scale by, and we print out the P. So initially the P is like the value is 1 and 2, but we we call the method, and it changed the value. It changed the original value. Here it's like time 2, so it's like 2 and 4. So that's the very common one to do, like especially if you have a like a map or slice, like which is like it's gonna take more memories in your memories. Is like very useful to do that with the pointer. Okay, so let's move on to composing type by struct embedding. So here, this is the example. Like we can embed another type to another struct to new struct. For instance, we have a struct called point here, and we have a new struct called colored point. So instead of like we doing like we pass the x and y here, we can just pass the another struct here. So for instance, for like we have a method in point, as you can see here, the method called distance that link to point struct. So if we have the color point and we initiate that, and we still able to call the method from point struct, is that we link in this struct, color struct, we link the point struct in there, and that come with the all the method that links to point. So it'll be very useful, especially if you have like more property, more struct members here, like 10 struct member, you know, and they have more methods. Instead of you add more methods to color points, we can just do it on this way. Okay, so let's move on to next, method value and expressions. Okay, I'll show you the example. So on here we have a point struct, we have a method, and for here that's the method value here. So we have a p here, right? We have a p here, and that's the method. That's the method. Then we assign the method to the variable called add, and we can just call the method here. But for the method expression, as you can see, this is a struct. This is not a value. This is a struct. That's the struct method here, and we assign that to here. This value add to. So in this case, that's the method expression. We can't really just pass in the param of the add method. We need to pass the receiver. We need to pass the receiver as the first param of add of here. So compare these two. So because this is p, that's the value, right? And this p is just a type, that's a struct. So for struct, you have to pass the first param that has to be receiver. Okay, that's the method value and the method expression. And we're gonna move on to next one called encapsulation. Okay, if you are from object-oriented programming, you are gonna be very familiar with encapsulation. So I'll just give you an example here. So we have a struct, we have a method here, and we have a method, another method here called value. That's the method called increment, and we have initial counter, and we add. We call the increment. Increment is like we add value to 1. So that's initially that's 0, right? Because we don't initial anything. That's the 0 value, and it's like 1. So the good thing about the encapsulation is we don't change the value straight away. It's not like here. It's not like we have a value called a variable called c, and we add it like this. This is like we don't change the value straight away. Instead, we use a method to change the value. The good thing about to change the value is like if something is like we can hide the complexity. For instance, for here it might be like a lot of calculation, a lot of checking. So we don't actually need to do that. What we need to do is just like we call this method and call the method value as well. It's like it could be, for this example, it's just like very simple to return the value, but in project it might be something like more complex, and by doing that we call a method here, and if we use the value, we just use like this. We call the method instead of like we use the value straight away. We call the method to return the value back to us, and it's like a more safe, and we don't need to know what exactly going on in this method here, right? And it just hiding a more complexity, and it can also secure the value here. Is like we don't manually change the value here because we call the method to change the value. Okay, so this is for, let me just give you a little bit more complex example here. That can reflect the advantage of encapsulation here. For this example here, we have a bank. We have an account, and we have a deposit and a get balance and a withdraw. So instead of the deposit, if you deposit, you like add the amount. Instead of add the amount straight to the balance, right? We just call this deposit. On here, this deposit, we have like we have a checking. We make sure that everything is correct, and if everything is good to go, and we can add the amount to the balance, and then like get balance as well. We return the balance, and withdraw. We have a loss checking here, and make sure that you have enough balance to withdraw. So this is just like a scenario that to saying that the encapsulation that can be like a lot of advantage when you're doing the project. We just hide the complexity, and we don't add a minus or to do anything with the balance, with the value straight away. We use the method to do the complex, to do the calculation, to do the checking for us. Okay, so that's pretty much for method, and I'm gonna upload this example to GitHub, and I'll see you guys on next week. Okay, bye then.